This is Winchester Academy.
So this is actually about the size of my mammalogy class. The weird thing is going to be that my students are always interrupting me with questions. So yeah, that'll be an odd thing to just talk on through. So yeah, any chance I get to talk about bats is a good day. And just why bats in the first place? And so this is a picture by Merlin Tuttle. And I think Merlin Tuttle needs a little bit of accolades here. He's actually was the curator of mammals at the Milwaukee Public Museum. And back in the early 1980s, he started an organization called Bat Conservation International. And that's one of the largest bat conservation organizations in the country, if not the world. And it started right here in Wisconsin, and before he moved it down to Austin, Texas. And Austin became one of the most bat-crazy cities in America. And I'd like to see Wisconsin be that passionate about bats. But anyway, he's really well known for his photography of bats. And so he took this picture of a little brown bat flying over Wisconsin, foraging. And when we think about bats, one of the important services that they do provide is they eat insects. And all of our bats here in Wisconsin, and I'll talk about some of those species today, all of our bats eat insects. But you'll also find out that not all bats eat insects. They eat a variety of things. So this little brown bat flying over Wisconsin can eat up to 4,000 mosquitoes in a night. Okay, so that's one bat per night. So my wife and I, when we lived in Dubuque, Iowa, we had 200 or 300 bats in our attic. And that colony of bats probably ate 500,000 mosquitoes a night. And so when we were living down there, I don't remember ever getting a mosquito bite when we lived in Dubuque, Iowa. Okay. So it's not just mosquitoes that they eat. They also eat larger things like moths. And if you know anything about moths, they were once caterpillars. And if you know anything about caterpillars, they can cause a lot of damage to leaves, and they can defoliate trees and crops. And so one study estimated that bats save up to $20 billion in pesticide costs a year just by eating those moths. Okay? So that's another big ecosystem service that they provide. There's something else in this in this picture I want to illustrate. They're catching these on the wing. There's a fancy word for it. We call them aerial hawking bats. It sounds really cool. It's an aerial hawking bat. It basically means a bat that catches insects in flight. Okay? And so I have this. I didn't bring any M&Ms, but it's a little bit hard to wrap your heads around catching something in a three-dimensional space. Okay? So anyone ever kind of like thrown popcorn up in the air and tried to catch it? Or have your friend throw popcorn at you and try to catch it? Okay, so try that. That's a good place to start. Just like throw popcorn at each other, try to catch it. Once you get good at that, turn the lights off. Okay, now turn the lights off and throw popcorn at each other. And once you're good at that, start running at each other as you're throwing popcorn at each other. And you'll get an idea of what it's like to be a bat as they're trying to locate a moth in three-dimensional space. Is it up, down? Is it left, right? And they're doing that 4,000 times a night. Okay, so it's a pretty energetically costly thing to do for a bat. When we forage, we just had dinner over at Simpson's, and it's a two-dimensional problem. You know, I had the chicken kebab plate, early bird special. It's right there on the plate. I don't have to do any fancy location of the food. It's in a two-dimensional space. It's not moving around, so it's a pretty easy thing for us to get our food. Okay. Another cool thing about bats is they're one of the most diverse groups of mammals. There's over 1,000 species of bat in the world. In fact, 1 in 4 species of all mammals is a bat. Okay, so it's a really diverse group of mammals. And And like I said, all of our bats eat insects, but once you get down, and it turns out it's about the 30th degree latitude, from 30 to 30 in the tropical and the subtropical regions, they eat a variety of things, including insects. This is a bulldog bat from the neotropics. These are fish-eating bats, so there's a few species of those. And they'll actually just detect the perturbation in the water in a very kind of a calm, calm water, and then they'll pick it up in their tail membrane. It's called, a fancy word is a uropatagium, so it acts like a basket. And actually, that's what they're doing with the insects too. They don't just like grab it with their mouth, okay? They grab it with a basket between their tails, and then they scoop it into their mouth, okay? And they're doing that 4,000 times a night. So that's pretty impressive. I guess that's an extra dimension to add to your M&M popcorn thing. I hadn't really thought about that. Okay. So we've got all of these fish-eating bats. There's a lot of fruit-eating bats. And so you've got the Old World fruit bats. You've got the New World fruit bats in the neotropics. The most famous being on the label of Bacardi rum. Okay, if anyone's ever heard of a drink called rum, Bacardi rum has a bat on it, and that's actually a Jamaican fruit bat. Okay, there's a whole history of why there's a Jamaican fruit bat on Bacardi rum. There's other bats that are nectivorous, so they'll feed on the nectar in flowers. Again, one of the more famous groups of those bats are the bats responsible for another alcohol, tequila. Tequila and sotal, those are made from agave, and agave are bat-pollinated plants. Typically, you have they're flowers that open at night. They tend to be white flowers. They tend to not have a lot of odor. The bats are basically just picking up on the shape of that flower and then pollinating those. Okay. So actually, Cuervo and Bacardi both give a fair amount of money to bat conservation, but for different reasons. Okay. All right, so now you've got nectivores, you've got insectivores, you've got frugivores, fruit-loving, and then you've got the three famous bats, the ones that feed on blood. Okay? And there are three species of true vampire bats. Two of them feed particularly on birds, and then one on mammals. Okay? It's the common vampire bat that feeds on mammals. It's found from Mexico all the way down into Argentina. Wherever you have large cattle operations, you've got pretty large populations of vampire bats. Okay. What's interesting about vampire bats, I'll talk a little bit about what's interesting about vampire bats, but they seem to have captured the imagination of a lot of people. Over 1,000 species of bats, and everybody thinks a bat is a vampire bat. Not true. So we've got all these great movies, and of all the bat movies out there, this is the one I'm going to recommend to you. It's called The Devil Bat. It is so bad in a very good way. When the bat is basically a kite, and then when the bat attacks you, the guy grabs the kite and holds it to his throat and screams, and it's beautiful. But it also stars Bela Lugosi. And if you ever saw Ed Wood, Martin Landau's portrayal of Bela Lugosi, this is the type of movie that is. It's really not a vampire bat that's in this movie, but Lugosi's performance is worth it. Most of you know Bela Lugosi as the original Dracula. Okay, and so this is 1931, and what I love about the original Dracula is how biologically accurate it is. When I watch bad mammal movies, and there's a lot of good bad mammal movies, I look for the biological accuracy. That's always the most important thing for me. That's not true, but in the original Dracula, you've got Bela Lugosi, and you see the silhouette of the bat by the curtain or whatever it is, and then all of a sudden he lands. Now he's Dracula, right? And then he walks up, to his victim, and he assesses, the victim. Where is the blood vessel? Where do I kind of sink my teeth in? Okay, that's exactly how vampire bats behave. Vampire bats don't just land on there. They don't just fly and flop on the cow. No, they land close to the cow, and then they walk. They walk up to the cow. They have infrared detectors in their face to figure out where the blood vessel is, close to the skin. And then they have anticoagulants in their saliva and anesthetics in their saliva so they can make an incision without the cow feeling it, and they keep the blood flowing. Okay. So all of those things are going on in a vampire bat. So they walk up to their prey. They have these detectors. They also live in these large colonies. Okay, they're very long-lived, and I'll talk about that next. Large colonies, and they share food. So the colonies tend to be maternal colonies. So it's a bunch of moms and pups, and a big babysitting co-op. Think of a big babysitting co-op. So one group will go out, get a whole bunch of food, okay, blood, and then they'll come back and regurgitate that to their pups, to their sisters, to their aunts, to their grandmas, to their nieces and nephews. So they're very generous that way. Okay. And they're really cute. Okay. So really when you think about vampire bats now, I want you to think about these guys. They're adorable. Okay. They're actually, just as a side note, they're related to, they're in a family, they're related to the New World fruit bats. So they're actually a modified fruit bat. Okay, those are their ancestors. Okay. Something else that's very Dracula-like, if you want to kind of stay on that theme, is bats are long-lived. They're not immortal, okay, but they're long-lived. You tend to think about smaller animals having shorter lifespans. Like think of like a rodent or a shrew, a year tops, right? Bats can live up to, this bat here, 33 years. And we don't even know. That's the minimum. This bat was captured outside of a hibernation cave in 1983, and it was recaptured in 2015. All we knew in 1983 is it was more than 1 year old. When you age bats, there's basically two categories. Less than 1 year, more than 1 year. That's as good as we can do. And that's because what we're using a fusion of the bones in the wrist. And so you put it on a light box, and you can say if they're unfused, it's this year's bats. If it's fused, it's older than that. Okay? And that's as good as we can do. But we do know that they live a pretty long time. Okay? So that's pretty cool. All right. Now, so bats are amazing. Hopefully I've convinced you that bats are pretty cool. But I want to take a little bit of maybe a dark turn and just talk about a few of the relatively recent threats that we have regarding bats. The one you may have, okay, I want to answer questions, but I will get a show of hands. How many of you have heard of white nose syndrome? Okay, so that is a relatively new threat. And so this is a picture by Paul White. This is a DNR of a northern long-eared bat. It's a federally endangered bat. And we tend to think of white nose because it first appears on the muzzle, because they're breathing, right? And so it just forms around the muzzle. But really it infects the entire bat. So here we're seeing the entire bat is infected with this fungus. And it doesn't kill the bat outright. What it does is it irritates the bat. It gets into the wing membrane and it can cause direct damage to the wing membrane. And if you're a flying animal, you kind of need a really good pliable wing membrane. But really what's happening is it's irritating the bat. It's causing it to arouse from hibernation. Okay. Now a lot of people think, and I think I thought this as a kid and an adult, that when you go into hibernation, you basically go to sleep. How many of you have chipmunks in your backyard, or 13-line ground squirrels, or something like that? It goes into hibernation and it comes out in April. It's not what happens. It goes into hibernation. It's in and out a number of times throughout the winter, and it takes a lot of energy to go from near freezing, which is what hibernation is, to bring your temperature up to about 37 centigrade or 98.6, which is when we take our temperature in Fahrenheit. About that temperature. So imagine, going to sleep, letting your body temperature go to 32, which is what a bat will do, and then you have to raise it up to 98.6. That takes a lot of energy, and they can only do it certain number of times per year with the stored energy that they have. What white nose is doing is it's causing them to come out more often, and they basically don't have the energy, and they just burn out. Okay. So it was first discovered in 2006, 2007 in a cave in New York State. It's thought to have been brought over by spelunkers from Europe, where we have, there is white nose, that fungus is there. But it doesn't cause this catastrophe of catastrophic event of bats. What we think, though, is that it did in the past. One thing that you don't have in Europe, in European bats, is the huge numbers that we have. You don't talk about caves with 20 million bats like we have in the United States. They don't have those kinds of numbers there. So it's thought that maybe they went through that catastrophe sometime in the past. Okay. Currently, we think white nose has killed between 5 and 7 million bats in the United States. It's known from 31 states now, 5 Canadian provinces. And in little brown bat colonies, it can cause up to 100 total colony collapse. Okay, so it can wipe out the entire colony of bats. But 90 to 100% are wiped out. And you can see from here, it pretty much followed down along the Appalachians, along the Ohio River Valley, up the Mississippi, and it came into Wisconsin in the southeast. Okay, first, that's where we first detected it in 2014. But there was also a northern route. It came up through here, through Ontario, into the Upper Peninsula of Michigan, and it also came in through the southwest and the northeast part of the state. So we kind of got hit in about 2014-15 from 2 different routes. Okay. A little bit of good news. So it's pretty bad. Let's just kind of say that in general. But last year, a group doing some genomic research found that this particular fungus lacked an enzyme that repaired DNA that was that was exposed to UV light, so ultraviolet light. Okay, most animals have mechanisms when it's exposed to UV light. There's a repair mechanism. This fungus doesn't have that. It's a cold-loving cave fungus, so maybe it just lost that ability. There's no UV light in there. So there's some new therapies now that even low doses of UV light will destroy most of the fungus. Okay, so this is a bat that is getting a UV light treatment. Now, that's a fairly labor-intensive thing to take every bat and give it a UV light treatment. So again, it's new. What I haven't read, what I think would be even more exciting, is to disinfect caves. I mean, I could see going in the summertime or something, or right before the bats come back with UV lights and trying to disinfect caves. But I'm not sure what's going on with that. But anyway, this is encouraging research here. Okay. Now, not all of our bats are susceptible to white nose. The 2 main bats susceptible to that are the little brown bat and the northern long-eared bat. And then we have eastern pipistrelles in the southwestern part of the state as well. That would also be susceptible to this disease. Okay. Another threat that some of our other bats, so we'll take a step back. So we have 2 flavors of bat. I don't know if that's the right word. 2 types of bats in Wisconsin. We've got the locally hibernating bats, like little brown bats, pipistrelles, and northern long-eared bats. These are bats that are going to fly pretty close by locally, find a cave, and hibernate over the winter. They're just not strong flyers. They're good maneuverers, but they're not going long distances. Then we have other bats that are strong flying bats that are migratory. They can migrate from Alaska down to Mexico. Okay, so they're strong flying bats. These bats are more susceptible to wind turbine mortality. Okay, and so with the growth of wind farms, and this is just information. I'm for investment in wind energy, but with the growth in that, we are finding some mortality. Some estimates up to let's just kind of like round it up to 1 million bats killed by turbines each year in the U.S. Okay, so it's a significant number of bats that are killed. What's interesting is it was once thought that they were killed by collision with the blade. Okay, what's happening though, we think, a lot of these bats are tree cavity nesting bats. So they're going to go look for a tree cavity to hunker down for the day, okay, and then they're going to just continue on their journey. Well, what does the wind turbine look like to a bat in a landscape? It looks like a tree. It's a tall vertical structure. So they're keying on that tall vertical structure. They're flying close to that, and they're flying through the rotating blade. The pressure on each side of the blade is different, and what's happening is their lungs are bursting. It's called barotrauma. Barotrauma. So, and then it basically, yeah, you can get a secondary collision. But it was actually a graduate student at the University of Alberta, a master's student, that went around and picked all these things up, bats up, did all the necropsies, and figured this out. And so you have to do the science. But pretty interesting. And these are just some that Paul collected near a turbine. You've got red bats, silver-haired bats, and hoary bats would be the 3 species that are particularly susceptible. All of them more of a migrating bat here in the state. Okay, so those are the 2 big threats: white nose syndrome and wind turbines. Okay, but a lot of people still want to know about rabies. Okay, and so just a word about rabies. Wild bats, the prevalence of rabies in wild bats is well under 1%. Very few bats actually contract rabies. Okay. But the other side of that is the #1 way that people get rabies in this country is from bats. Okay, we're talking like 18 people, over years. So it's not a lot. But of those 18, most of them are from bats. You may know or heard about Jenna Giese from Fond du Lac, who really has a heart for rehabilitating animals, and that's where she got bit by a silver-haired bat in Fond du Lac. She goes to all of our bat festivals. We have a bat festival every year, the Wisconsin Bat Festival. I highly encourage you to go. It's been in Milwaukee the last couple of years. This year it's in Ashland, and I'll tell you why it's in Ashland, I think, in just a bit. But Jenna is very passionate about educating people about bats, and she still does rehab. And she just got married and had a baby, so she's doing great. Because of this, just a bat that you can get your hands on is probably a bat that you shouldn't get your hands on. Okay, at least not without some type of protection, even light gloves. But I would still suggest calling a local professional or someone that's used to handling them. Okay, so that's the one thing. If bats flying around, I would have they're not rabid. You don't know why you can get your hands on the bat. Chances are it's exhausted for some reason, but better safe than whatever. Okay. All right. So in response to these threats, the Wisconsin Department of Natural Resources started the Wisconsin Bat Program, and much of it was the thinking about Dave Rettel, who left us at a very, very young age, unfortunately, from brain cancer. But this is him outside the Needham Mine, which is one of our largest hibernacula in Wisconsin. It's down near Horicon. And Dave really had a passion for bats, and he started this program, the Wisconsin Bat Program. And what I love about the Wisconsin Bat Program, it's a collaboration between bat biologists and bat scientists and citizen scientists. So we have the bat ecologists. This is Paul White from the DNR is in here. Dave's wife, Jennifer Rettel, here. One of my former graduate students, Jennifer Summers, here. So they're going in every winter and looking for bat mortality, looking at white nose syndrome, doing all the work, trying to locate every single hibernacula that we have in the state. Okay, so they're doing that legwork. And then there's a site here that invites citizens to collaborate, to collect data and to upload data. Okay, So you can go to that, and there's a couple ways that you can volunteer. One is roost monitoring. Okay, so I was just talking to someone before I got up here that has some bats on her property. And so this is a way to share that data where you would actually go and identify a roost on your property and then basically do a census and then upload that. You'd say, this is where the property is. I'm somewhere in Waupaca. This is how many bats I have, okay? Without necessarily knowing what kind of bats you have, okay? Just giving a roost count, okay? Another way to participate is doing acoustic monitoring. I'll talk a little bit more about that. It's really going out with a mobile unit and doing a walking route or a route with a boat, or actually they have driving routes now. This would require, at least in its current form, you getting a mobile bat detector. I don't know if Phil's here, but there is a Waupacian. Is that what you guys are called? I don't know. And doing the walking route. What those look like, just this is a group I work with in Milwaukee, the Urban Ecology Center. We've got the unit here. It's actually an Anabat from Australia, is the company, Titley Electronics. There's some technology here that you can visualize the bat call as it flies by. You can record that bat call. This is a GPS unit, so you can geotag that bat call. And what's cool about this is it really is an educational opportunity. So this is Lynette. She's a Cuban bat biologist going out with a group in Milwaukee, if you know where the Three Bridges Park is, and along the Menominee River, right by Miller Park. And so just walk around and you look for bats. But then the important thing is they're coming back and then they're uploading that to the Wisconsin Bat Program site, and then the biologists, the DNR, are looking at that data and putting it into their larger data set. Okay. All right, in addition to the mobile routes that we're doing across the state, the state established 5 permanent bat monitoring sites. These are just, this is what they look like. So this is one in our backyard in Yahnke Reserve on campus at UWSP. It's the best one because if you know anything about Yahnke Reserve, they love making their really cool signs. And so we've got the best sign of any of the bat detectors. You know what it is, and you know it was established here in 2007. So the Wisconsin Bat Program really got started right after the discovery of white-nosed syndrome. They didn't waste any time, which is really cool, to get some good baseline data. So now that unit is in here. It's in a waterproof box. You've got a cord running up here. Here's the microphone facing down, so it's weather protected. There's a little plexiglass thing here that you can't see. So the bat will fly, it'll hit the plexiglass, it'll bounce up to the microphone, the call will go down and be recorded here on data cards. And then Jim or whoever's in charge for each of the different stations will physically take that card out and upload that data to the DNR. Okay. The data looks a little bit, well, not a little bit, it looks very much like this. So this is called the sonogram. Okay. So it's the acoustic signal of the bat. And they're pretty species specific. You can see a little bit of variation here. This is a little brown bat call. Here you've got pitch. So pitch is in kilohertz. Is it a low pitch? Is it a high pitch? So that's kind of your pitch. And so here we've got a pitch at around 40 kilohertz to 80 kilohertz in a little brown bat. It's what we call broadband. So it's sampling a lot of bandwidth. Okay. It's getting a lot of information. It's a small bat. The higher the pitch, the smaller the insect that it can eat. Okay, so that's one little piece of physics that you should know. Okay, high pitch, small insect. Okay, so we have the northern long-eared bat has a pitch that goes up to 100 kilohertz, and it can pick a mosquito off of a leaf. Okay, it's a gleaning bat. That's how awesome that bat is. Okay. So this is a little brown bat. This is a red bat. It's got a slightly different shape. Okay, but when you look at these enough, you know, a bat biologist or what I'm working with now, a citizen scientist can say, yep, that's a little brown bat, that's a red bat, that's a hoary bat. Okay, and really here in Wisconsin, you only have to keep track of 8 species. That's all we have, 8 species of bat. And 5 of them really are going to be your common bats that are going to be flying around on any given night that you'd have to ID. All right, so that's what we did. So we went through and we basically took all the data from this detector, and then I've got data from 3 more. And my students and I have been going through with auto-analyzing software and visually, manually, just by eye, and scoring all of these files. Okay, so that's what we've been doing. Now, when you do that, you start to get a picture. Okay, so we're just going to look at some of the data now. Okay, so one of the, I'm not going to say problems, one of the issues with what we're running up against with the Wisconsin Bat program is there's not enough of people power at the DNR to actually look at all this data. Okay, they're going through funding cuts. They have to kind of prioritize their work as well. So the bat data is there, but no one's looking at it. So what I'm trying to do with my students, with citizen scientists, with people at Urban Ecology Center is, let's look at this data, okay? Because it's not doing anything sitting on a server in Madison. All right, so this is Kemp Natural Resources Station. This is one of the stations that I work with up near Tomahawk, Woodruff, Minocqua, Lake Tomahawk area. And this is just looking at all the bats. So we're just taking all the bats ever collected at this station that I could identify. Okay, so that's what you're looking at. It's about 50,000 bat calls. Now just a little orientation. Over here on your y-axis is activity. Activity is the number of bats that flew by a microphone. Okay, it's a proxy. It's not exactly the same as population. Okay, because it might be the same bat flying by. Okay. So it's a proxy for population size, but it's not exactly the same as. Okay, so that's activity. Just to clarify what you're looking at there. And then this is just years. Starting in 2009, when that bat detector was established, until now. Okay. And so right away, just when you do that, when you put all the information together, you see, bang. As soon as white nose syndrome shows up in Wisconsin, the northern Wisconsin bat populations just fall off the cliff. Okay, so that is pretty scary. But this is just all bats. Now we have more detail than that. Okay, so we know, once we start looking at the data, that the common bats flying around on Lake Tomahawk are the red bat and the little brown bat. I mean, they are the 2 main bats. Okay. This bat is very susceptible to white nose syndrome. This bat isn't. Okay, that's more the bat that's more susceptible to wind turbine damage. Pretty scary. So here's 2013, the year before white nose syndrome. Here's white nose syndrome. 2 years there. This is the current populations of little brown bats. Just completely, you go out there with the bat detector now, and it's like, it's quiet. It's frighteningly quiet. But what's interesting about this data, now that we're looking at it, is you see a drop-off in, first of all, we talk weird in bat biology. Epfu is Eptisicus fuscus. That's the scientific name of the big brown bat. Okay. So I tried to, red bat is Labo lazius borealis. So that's bat speak. You know, so bat biologists tend to say lazi, lano, milu, but really there's code. Bird people are the same. I don't know if you know any birders. They talk like that. They go PIFA and Cora, you know, for peregrine falcon and common raven, but they use common names. That's not so good. Okay, so yeah. So this is a pattern. I'm not entirely certain what it means. Okay, so we wouldn't have expected red bats to fall off with white nose syndrome because there's not a lot of evidence that they're susceptible to it. This is another pattern that we saw up there, and we're seeing it a little bit down in Milwaukee. These are hoary bats. Hoary bats are typically a very uncommon part of the acoustic profile relative to some of these other bats. But as little brown bats went down, hoary bats just shut up. We don't know what that means. What I think it means, hoary bats are very high-flying bats. So it's not that they're uncommon, it's just that they're flying way above our microphones, way above our microphones. But now that the eco space down closer to the ground is being vacated by all those little brown bats. The hoary bats are basically flying closer to the ground. That's just my hypothesis. But we wouldn't have known it if we didn't actually look at the data here. Okay. All right, so like I said, we have I've got 5 detectors around the state. I have access to 3 of them, one in central Wisconsin, one in northern Wisconsin, one in southeastern Wisconsin. And so this is quite interesting. When you think of the bats that are susceptible to white nose syndrome, it's in northern Wisconsin. Most of those are being recorded in northern Wisconsin. They're up over all those beautiful lakes that we have up there, picking off mayflies and picking off emerging insects, we think. So this is really our Myotis bat haven is northern Wisconsin. Down here in central and southeastern Wisconsin, they occur, but they occur at much lower levels than we have them up north. Of course, now it almost looks like they're more common in Schmiegli in central Wisconsin. Okay. So those are our Myotis bats. Now we have 2 species of Myotis bats. We've got the little brown bat and the northern long-eared bat. This is federally endangered, and it is about 10 times rarer than the little brown bat, just when you kind of look at the numbers. So this is all stuff that we're just pulling out of the data. Again, northern Wisconsin is going to have the lion's share of these recorded little brown bats. Okay. All right. So I'm doing work right now in Milwaukee with this really wonderful organization called the Urban Ecology Center. If you haven't been down to, if you get to Milwaukee, I would encourage you to go. They have 3 campuses. This is Riverside Park on the east side. They've got one in Menominee River Valley on about 37th and Pierce, and Washington Park. So it's pretty much an urban inner city type of nature center, and they're doing really cool things. And so their bat detector, their permanent station, is pretty close to the Milwaukee River, not right on it, but it's a nice habitat. Well, I just started looking at the data in the last month, so you're the first people to actually see this data. When you look at all the stations, Milwaukee just has a lot of bats compared to the other stations that I've been looking at. And those bats are predominantly big brown bats and silver-haired bats, those 2 bats. And these are bats that feed mostly on moths, so they're larger-bodied bats feeding on a variety of things, but I think a lot of moths. Something else that's interesting, again, here's that Kemp, all that data. So this basically is swamping out what you've been looking at with Kemp data. And then this is the red bats. The red bat is one of our species that's pretty equally distributed across the state. Okay, so that's, I would say, we're going to find it here in similar numbers as we find it in northern Wisconsin, as we find in southeastern Wisconsin. But the other bats are pretty regional. Myotis bats in the north, big brown bats and silver-haired bats in the south, okay, and in the southeast. So Milwaukee has a lot of bats. In fact, this is about 100,000 files, bat calls. I've got a database that's about 300,000 bat calls now from these 3 stations. So 1/3 of all the calls that we recorded from these 3 stations have been big brown bats in Milwaukee. So that's just to give you an idea of how common they are. Okay. The other cool thing, or the other interesting thing I think about Milwaukee is their bat populations don't seem to be going down in response to some of these threats. They seem to be pretty stable, if you will. Again, here's Kemp. Here's white nose syndrome, kind of falling off here. This is what happens sometime with these acoustic monitors. They fail. Okay, so we've got a couple of years where the monitors just weren't working. Okay, so we're missing data. In fact, this year here is incomplete data. I have it in there, but there was a couple months where the monitor wasn't working. So you can't go back and recollect that data, unfortunately. But it gives you an overall picture that For the most part, you've got a couple good years, but there's not a big dip associated with white nose syndrome in Milwaukee. Okay. Which means that from an educational point of view, if I'm going to go out and take you on a bat walk, I can go out in Milwaukee and do that and be fairly confident that we're going to find bats. If I do that same bat walk in Woodruff or Minocqua, I can't really guarantee that we're going to have a lot of success finding bats. So it's one of the, I wouldn't say that's why I went to Milwaukee, but I think from an educational point of view, we can get people familiar with how to look at bat data. Okay. A word about about manually scoring a sonogram, okay, just looking at a sonogram versus having a computer do it, because that's a bit of a point of contention with some organizations now. The DNR is not entirely on board with some of the automated software programs, and there's with some reason, and this is an example. When I was looking at the 2008 data at the Urban Ecology Center, there were all of a sudden 40,000 hoary bats. And I'm like, it went from 400 to 40,000? That doesn't really make a lot of sense, okay? So I started looking at the actual data, and this is, a lot of it looked like this. This is basically some kind of mechanical background noise, or it could be crickets. I actually made some audio files and listened to it. It sounded more like water. It was something was wrong. But the computer called that a hoary bat. All the computer saw was there's something between 15 and 20 kilohertz. That's where hoary bats are. We'll call it a hoary bat. What the computer didn't see is this. That's a bat. You as a human being are actually better at this than the computer. You know the difference between that and that. You can visually distinguish that. With a very little training, I can tell you that this is a silver-haired bat, and that really is the only bat in this picture. And so what we have is a lot of information that is being masked by some mechanical noise. So one of the things that I'm trying to do is get citizen scientists and high school students to actually manually look at a lot of these and say, yep, that's not that. That's something else. And so there's a lot of data that we're missing because of some problems like this as well. So still working on that. Okay. The technology now is really changing for citizen scientists. So this is I brought one with me if you want to see the actual size. So this is just an iPad. Looks like an iPad 4 standard size with a microphone on it. And that microphone it's called an Echometer Touch. That particular microphone is you can now get for between $150 and $350. Okay, so $150. This is an app that goes with it, and then you can get the app upgrade that'll do the auto ID. Okay, so for about $300, you can actually have a system, and for birders, when I talk to birders about this, that's about what they'd pair for a really good pair of binoculars, like really good binoculars. So for $300, you could actually have a system that records bats and identifies bats. Okay. So one of the things I'd like to see are just more of these devices in the hands of people to go out and look at their local bats. Okay. This is an example of a map that you would get for that. If you've got GPS data on your machine, or if you've got some way to geotag that, it'll actually map those for you. It'll identify them and map them. And so you'd have a neighborhood bat map. Okay, so that would be cool. Well, this is where I teach in northern Wisconsin at the Kemp Natural Resources Station. This is the location of the actual permanent bat station. So last year we went out with some an Echometer Touch in some canoes at about 11 o'clock or so, and we just did a canoe route. And what we found were a lot of little brown bats flying around over the lake. Okay, and those little brown bats were not being picked up at this station. Okay, so one of my, I don't know if it's a concern, but I think we're underestimating little brown bats. We need more people out on the lakes in the summer looking for these little brown bats. But again, it can't be a few DNR biologists. It's got to be thousands and thousands of Wisconsinites that are interested about bats out there looking for these bats. And then sharing that data. So one of the things I'm working on this semester down in Milwaukee is a protocol to go from this to actually a way to share that data with the DNR, or to share that data in some other platform nationally. And what's kind of inspired me are these guys. So every Thursday I go out with citizen scientists at the Urban Ecology Center birding. And so they've got bird groups that work on Tuesdays, Wednesdays, and Thursdays at their different campuses. And if you've done any birding, birders are really good citizen scientists because they don't just go out and bird. So here we are birding in Milwaukee. We started up on the tower at the Urban Ecology Center. And then we come inside, and then Jennifer basically logs on to eBird. And she logs on to eBird, and then we upload all the data that we just collected. Okay, so I'm talking to John. So this is one of the volunteers, John. And I'm like, this is so cool. Because if you think about the way birders operate, you could sit in a chair and wait for birds to fly by and then count the number of birds. Or you could do a walking route. But you're going to get different data doing a walking route versus sitting. So here we've got a permanent bat detector at this site that's basically just like, it's in one place. But we need to do more walking routes, okay? But then we need to be like these guys. We need to take that data and upload it in some fashion that it can be shared nationally and internationally. And that's what eBird does. So I've got this idea, eBat, that we would have a similar group of people doing this. I told John that, so we're out there last Thursday. I'm like, hey, what do you think about eBat? I'm going to get everyone out there batting. And this is what John said, night comes at the wrong time of day. Okay. And I'm like, touche. But what birders do, birders will get up, they'll go birding, they'll come in, grab coffee, upload to eBird. Okay? It's the first thing they do in the morning. Well, this is more data from our bats, right? So we know that most of your bat activity is like the first hour after sunset. Okay? If you're going to go out batting, you go out right at sunset and you just go for an hour. So the bat protocol would be go out at sunset, bat for an hour, go home, grab a glass of wine, and enter your data into eBat. And then go to bed. Okay, so now you can do your birding in the morning, you can do your batting at night. Okay, so yeah, there's some potential here, in my opinion, anyway. Okay, now, maybe bats aren't your thing. Maybe I haven't convinced you that I'm going to go out and do bats, and that's going to be all rosy. There's still a lot of other ways that you can get involved in citizen science and community science. And really down at Urban Ecology, they like to call it community science because it's a local activity that you can do. Like bat stuff. There's a wonderful site, if you don't know about it, called Zooniverse. Okay, Zooniverse.org. And they have a lot of different things that you can get involved in. And it's not just biology stuff. There's history and medicine and literature. This is one of my favorites here. It's basically having a human look at old museum catalog notes and then just transcribing them so it can be digitized. Because have you ever seen like those 1800s writing? It's like really hard for a computer to read that. It's a little bit hard for you, but you can do it better than a computer. So you're basically just typing in dates and specimen tags, and you're just helping out as a citizen scientist. If you want something more local, one you may have heard about is Snapshot Wisconsin. Snapshot Wisconsin is really cool. It's a lot of trail cameras spread around the state, hosted by schools and all sorts of groups. Okay? So you put out a trail camera, someone that hosts that camera takes those images, uploads them to Snapshot Wisconsin, and then they post it to the Zooniverse, where anyone in the world can look at it. And what you get when you log on to, you register for Zooniverse, you log on to a project you want to do, like Snapshot Wisconsin, and then you're just given a series of images. So here's an image from a trail camera. Is there anything in it? So there's a lot of blank ones. And that basically saves the scientists in Madison from even dealing with those. It's like, it's blank, it's blank, it's blank. Okay. A lot of deer. I don't know. That you probably wouldn't have guessed that. No. There's a lot of deer, so you get a series of 3 images. And then you get basically how many deer, are they young, what are they doing. So you're actually providing, and if you get thousands of people doing this, you're getting a lot of data. I was just at the Fish and Wildlife meetings in Milwaukee, Midwest Fish and Wildlife meetings, and I saw a poster by a student at Northland College in Ashland that used Snapshot Wisconsin data to show that northern bears hibernate, longer than southern bears. Okay, it seems intuitive, but she actually could show that with camera data. Okay, so it's really cool. All right, well, I hear that we are going to be kicked out in about half an hour, so I thought I'd leave some time for questions. Thank you. Ashland?
You're going to say something about Ashland.
Oh, Northland College, Ashland, I think.
Oh, Bat Fest.
Oh, Bat Fest, yeah. Thank you for reminding me. So
Raise your hand if you have a question.
So the Wisconsin Bat Festival has been going on for, I want to say, 6 or 7 years. It's really cool public education opportunity. There's always this guy with like large flying foxes there. The kids love live bats. And a lot of organizations there talking about what they're doing for bat conservation. And then there's a science panel and stuff like that. So it's been in Madison and it's been in Milwaukee. Okay, but this year it seems like an outlier that it's in Ashland, which is way up on Lake Superior. And I think one of the reasons, in my opinion anyway, is that's where all of the threatened bats are for white-nose syndrome. All those little brown bats that I was talking about, that's where they're, that's the area. Okay, so we're going to try to get people focusing on little brown bats. That's the population target, those northern Wisconsinites. It's usually in September or October. If you go to the Wisconsin Bat Program website or the Wisconsin DNR, Wisconsin Bat Program, there should be a Wisconsin Bat Festival link that you can find out more information. It's only 4 hours from here. Short trip. Yeah.
Other than,
Right? I can probably hear you.
other than disease and wind turbines, are there any natural predators?
That's a great question. Are there any natural predators to bats? Here in Wisconsin, not many. One of the reasons we think bats live so long is they don't really have a lot of natural predators. They have really low, they give birth to a single pup per year. Okay, now that makes sense, right? I mean, if you're flying around with your baby, that's kind of going to take a lot out of you. So there's generally a single pup per year, except for actually some of our. I'm not answering this question. Okay, so anyway, other threats to bats. No, they have really what we call low extrinsic mortality rates. There's not a lot of things that kill bats. Okay, in other parts of the world, you may have seen this really great documentary by Attenborough, Life in the Undergrowth, that shows these centipede-eating, bat-eating centipedes in Venezuela. I don't know how common those are. There's tent bats in Costa Rica, the ones that use heliconia leaves, and spider monkeys will grab those and just have a little bat burrito. But here in Wisconsin, not so much. But good question. Yeah.
Last year, just on. Anyways, last year in Stevens Point, we lost all these trees. Did that hurt the bat population?
It could, because a lot of bats use tree cavities for roosting. So if there were trees that had cavities or bark that bats would naturally kind of go behind, they would have had to look for an alternative housing experience, as it were. But bats or trees on the landscape are going to be important for for bats because it's going to provide day roosting sites mostly. So that bat trees are important. Yeah.
Okay, it's working. Okay. I was just wondering if bat houses or similar artificial environments have any effect on your data collection. Good or bad?
Well, if you have a bat house and you're monitoring it as a roost, like it's an active bat house, then yes. So that's going to be data that the Wisconsin Bat Program would use. Those of you that have done bat houses, you may know that they're somewhat hit or miss. You know, it's like, because you can't, I think one of the things people do is that it's like, I have 300 bats in my house, I'm going to put a bat house here to entice them into the bat house. Well, come on. I mean, are you going to go from like the Hilton to the Days Inn? I mean, you're really, and so putting up a bat house, I think, is still good, and it's actually an outward manifestation of your love of bats. Whether or not it's going to be occupied is completely up to the bats. And if it is occupied, and you monitor that, then you are providing good data for us. Yes. Okay. There's a hand up way in the back.
We used to live in Montreal, Wisconsin, which had the mines, and the houses in the area had slate roofs. And I still remember when any of the roofs were replaced, it was like you couldn't believe the amount of bats that flew. Are they still as much in existence up there as they were at the time? There were bats all over the place.
So Montreal, Wisconsin is
Pearly?
Pearly? Oh gosh, I wish I could say yes. And I'm thinking the slate roofs. If I was a bat, I mean they're such good thermal tiles in terms of getting under there and holding some of that thermal heat. If I were a bat, that would be a great place to hang out, right? But I think a lot of those bats may, well, first of all, without knowing what bat, well, you saw the data from Count, that would be similar to Hurley. A lot of little brown bats up there. And so if you're talking about large colonies of bats under those tiles, those could be little brown bats, and those are the populations that are going down. Hurley would be up in that, the copper country and all that, all those mines up there would be those are the exact hibernacula that are getting clobbered by white nose right now. So what we're really looking at, I think, over the next decade is the recovery cycle. I mean, it wasn't gradual from the data. It's not like they gradually went down. It's like bam, bam. And now it's like, what's going to happen next? Are they just going to disappear, or are some of them going to build up resistance, or are we going to figure some of this out as wildlife biologists and start to see some recovery? Okay, and so that's really what we're trying to focus on now. And so every bat that you see under a shingle is an important bat to record. Yeah.
We have a farm with many outbuildings, and of course we see bats in the barns and in the sheds. But we're those people who put bat houses out hoping that they didn't stay in the houses, which they do. And I'm just wondering, what is the best way to deal with bats in the house? Bats in your belfry? I don't
know. As someone that's had bats in the house, and as much as I love bats in the house wasn't a popular thing in our house. And so we did call a specialist, and down in the Dubuque area, along the Mississippi corridor, that a lot of bats down there. And really they are federally protected, so you can't just deal with it yourself. Well, legally you can't deal with it yourself. So I would, if that's a concern, you'd want to call an expert, and they would be able to do a couple things. Figure out where the bats are getting in. So they would also probably not do anything about it until the time when bats left. They'd also be able to tell you what bats they were. They should, if you're paying them, they should be able to tell you that. The technology's there. And so, are you dealing with the Myotis bats? You should know as a property owner, what bats you have there. And then, because that's going to tell you about the biology. So, are they going to migrate? Are they resident bats, or are they just kind of like hanging out? Oh, here's another fun fact about bats I neglected to say. Here's a fancy word, write it down, philopatric. They return to their birthplace, okay? The females do, okay? So if you've got bats in your attic and you're a new resident to that house, that bat was there a lot longer than you were. It's their house. It's their house. Okay. So, and they're coming back with their actually their daughters, not their sons. They're coming back with their daughters and their sisters and their aunts and their grandmas and raising the next generation of bats. That's what you have there. Not that I'm saying that should make any difference in your decision, but that's what's going on. And then when they leave, they're going to go back and hibernate. That's when your bat guy should come and seal things up. If you have a bat house in place, those bats are going to come back, figure out that they can't get back in, and then they're going to look for their alternative lodging, and hopefully that's when your bat house is going to come in handy. So
the bat experts will know when they're going to be hibernating, or so
they should know.
Yeah,
the bat swarm is going to be in September, October, if it's little brown bats. So they'll probably come in October and start sealing things up. So you don't want to do that in summer, or at least you don't want to do that early in summer. The pups fledge in about early July, and then the colony might disperse. So you might be able to take care of some of that later in August after the pups have fledged, after they've flown away. But the bat people should be able to give you those timelines, okay? And if they don't have them, call me and I'll find you someone that can do that. Yeah. Okay.
We got one over there.
But another big question brought up, what happened with the sons and the dads?
Yeah, I didn't really want to bring that up. So they're solitary.
He asked what happened to the sons
Where are the
and the
guys?
dads.
Where are the guys?
What happened to the
Yeah,
guys?
where are the dads and where are the male bats? And male bats are solitary. So they're not the ones, if you've got bats in your attic, the only males in that are the first year pups, the sons. And they'll fledge and that's going to be the end of them. The rest are going to be females, taking care of like just the big happy co-op of babysitters, okay? Yeah, so the males basically are solitary. The only time that they're together is in the winter in the hibernacula. So they come back for hibernating, and another fun fact, the only time that they mate is basically when they're hibernating. Okay? So the male comes out of hibernation, mates with the frozen female. The female stores the sperm until she comes out of hibernation, wakes up pregnant, like, what the heck? So there you go. Anyway, yeah.
My question was what happened to the males too. But so they become solitary. They're still buzzing around all summer and
Sure.
finding a place in a tree during the day, but just not with others.
Not with they're not with others. Yeah, so they're not colonial like the females. And actually, after the pups disperse, the females disperse too. So mostly when you find bats in your belfry, it's spring, early summer is most. But you still want to monitor that, because DNR would still be interested. If there's large colonies of bats anywhere in the state right now, the DNR wants to know about it. But yeah, I understand. You don't want them in the house. Another word about bats in the house. A lot of the bats that get into the house, here's a fun fact, they don't want to be in your house. They don't. They're trying to find the path out of the house. And a lot of those are first year bats. They just took a wrong turn. And so they're just trying to get out. Okay, so yeah, so if it's in your house, it means you probably have them in your attic or somewhere else, and it just got into the house. But it's scary. It is. Yeah, just do the bob and weave. Okay.
Working.
Yeah. You mentioned that vampire bats, for the most part, are in Central and South America.
Yes.
That's the same latitudes around the globe, like in Africa, the subcontinent of India. I've heard that vampire bats have been a very serious problem in Australia.
No vampire bats in Australia. So all of the vampire bats, all true vampire bats are neotropical. They're only found in the Americas.
Oh, okay.
So no bloodsuckers there.
All right, glad to hear it.
So I don't know what's getting bad reputation there. So a lot of they have a lot of flying foxes and a lot of fruit bats. They've got a lot of insectivorous bats. I don't know of any fancy word sanguivorous, any blood-feeding bats in Australia.
Now the flying foxes, that rings a bell associated with Australia.
Yeah, so they're going to be they're fruit bats. Yeah.
Okay.
And they're the non-echolocating bats. So they're flying completely on sight and smell. Yeah, so they're not fancy.
They gotta see the M&Ms.
They gotta see the M&Ms. Yeah, or the mango or the date palms or whatever it's going to be. Yeah.
Thank you.
Yeah.
Do the vampire bats ever suck blood from other mammals besides cattle?
Sure.
Like people?
I have only heard rumors of drunk campesinos, but those are just, in Paraguay, they'd be like, oh yeah, so this guy got bit by a vampire bat and disappeared. Not likely, but mostly livestock types things like cattle is king down there. The #1 beef consuming country in the world is Argentina. I mean, that's, followed by Uruguay and Paraguay. I mean, you think we eat a lot of beef? No. That's beef central down there. It's like huge estancias, huge ranches, lots of cattle. But where you have sheep and where you might have other things as well. But it just turns out that I think from because of that, more the subtropical area, a lot of the other livestock are getting into more temperate and like sheep and stuff like that. But yeah, if it's got blood and it's accessible, they'll take it. I don't know if that answers your question. So yeah.
If people want to volunteer,
If someone wants to volunteer as a citizen scientist, how do they go about signing up?
I would suggest if you have something like the internet, to start with the Zooniverse and just kind of see what's out there just globally as something to do. I'm going down to, my mom lives in this place called The Villages in Central Florida, and I'm hoping to talk to some of the residents there about this really cool citizen science opportunity called Eyes on Owls. It's research on Alzheimer's, and they're looking at blood flow in brains. And the best way to figure this stuff out is for humans to look at it and say, is this a stuck vessel or is this not? And so those are all basically online games that you can sign up for. You just have to know about them.
Can I answer that, Chris?
And Mary can answer that.
We have here in Waupaca 2 classes every year called the Wisconsin Master Naturalist Program that teaches you how to be a citizen scientist. And we actually, here in Waupaca, we have the Pope Lake State Nature Area where we do bat monitoring and lots of different citizen science initiatives. So Sue Eiler, want to raise your hand where Sue's in the back. Sue and I are the teachers of that class. We've got a class starting in just a few weeks in April. You just get online through the UW Extension. It's the Wisconsin Master Naturalist course, and it'll teach you how to be a citizen scientist in the area that you're interested in. So if you don't like bats, no problem. You can be a citizen scientist in other areas.
But you're not saying being a master naturalist is required for being a citizen scientist?
No, that's correct. It just gets you connected to other volunteers and other scientists. Actually, Chris is going to teach in the Master Naturalist class, so we have guest speakers in all different. So it's just a way of getting linked into local initiatives for citizen science. But you're absolutely right, you sure don't have to be a Master Naturalist to be a citizen scientist.
You could go home tonight and sign up with Zooniverse and get plugged in with Snapshot Wisconsin and start looking at images. You could find out if anyone here is in the summer doing bat walks. I'm not sure what nature centers are local here that do stuff like that.
Okay, we have time for one more question, and then we're going to need to close this evening. We've got a question over there. You want to give them the microphone?
You flew it out last time, so there you go.
Is there evidence of interbreeding among the various species?
Evidence of interbreeding among the various species. Here in Wisconsin, not as much. There's the Jamaican fruit bat, this Artevius is the genus. There are some hybrids. There's one called Intermedius that's like kind of a mix between these two species, so they think it's more hybrid. I'm not sure. I don't know much about the Lazio bats in Wisconsin, but I don't think so. So I'm going to go with not a lot of evidence, but I know some South American species that there's some evidence.